Hello, and welcome to Revolutions, the show where we talk about the gear industry. I'm your host, Randy Stott, and today I'm here with Gottfried Klein of the Gleason Corporation. So thank you for joining me today.
Hello. Thank you.
I'd like to talk a little bit about chamfering today, and in particular, there seems to be a lot of more interest in it these days, especially a tighter control of the process and integrating chamfering in line with other processes. What do you think is driving that today, and what can you tell me about it?
Yeah, chamfering goes, or request for chamfering goes back a couple of decades when helical gears started to get more common. And with overcarburized edges, there was a danger when you had a flank load edge contact that particles could break off the edge. And at this time, customers or gear manufacturers required more tighter control of a chamfer or deburring process. And at this time, chamfer rolling was developed to get a defined chamfer. Over the years, especially when hard finishing picked up more and more, burr-free flanks were more important or became more important, especially when you think on power honing. Here, burrs inside of the flank or at the flank position where the chamfer starts could decrease the tool life of power honing tools. So burr-free flanks were a need, and then a second hop cut was developed, and so that lead to other developments like burnishing wheels to get rid of this burr. And finally, when dry cutting got more and more popular, it was with chamfer rolling. It was a little bit difficult to keep the tool cost significant down, like with wet cutting. And then chamfer cutting processes started and picked up quite a lot. And this is why Gleason developed Chamfer Hobbing as a chamfer cutting technology to get defined and precise chamfers.
So what is chamfer hobbing? Tell me a little bit more about that.
Yeah, chamfer hobbing is a newly developed process. Actually, chamfering by hops is not so new. That's as well something what is known for some time. But we developed now the process further on to be used on current machines with current technology, with new technology software. Yeah, and that's of course as well targeting the tight tolerances, what our customers or gear manufacturers are looking for.
And how does chamfer hobbing reduce costs?
Yeah, chamfer hobbing is basically using hops for chamfering. So you have a hop for the left side of the flank and one for the right side of the flank. And the hops have they are real hops, but they have an asymmetric profile. Yeah, so you can use existing resharpening facilities for resharpening this hop, and you can shift the hop when it's worn out at one position, and all this is decreasing the cost of chamfer hobbing. We were doing calculations and we found out that we can reduce the cost per part down to less than 3 cents per part, the tool cost per part.
Okay. And how well does chamfer hobbing control the process compared to other ways of chamfering and deburring?
Yeah, with chamfer hobbing, we developed as well a simulation software in order to define upfront exactly the chamfer which we can achieve on the workpiece. So of course it's always following the requirements of the gear manufacturer, but we can define upfront the chamfer angle, the chamfer size, the chamfer form, and then when we manufacture the tool, the customer will get together with a chamfer hob a data set for the setting, and we will be able to cut with the very first part already a defined chamfer, and then there are some small ways to adjust the chamfer width, but the precision is incredible what we are achieving with chamfer hobbing.
So what applications is it well suited for?
Yeah, this is right now, as we have dedicated chamfer hobs, this is medium and high volume production. We are looking for disc type parts to run as well as shaft type parts. And as I said, with dedicated tools, there is not so much flexibility. So the tool is really designed for one workpiece. The machines where it's applied now, it goes up to module 4 approximately. So in the range between module 1 and module 4, that's where we are using this technology. Some customers are looking for more flexibility. This is not what chamfer hobbing can provide, but there are other chamfer cutting technologies like chamfer contour milling with a fly cutter, where we are using standard indexable inserts to cut a gear with multiple cuts. And here we have a full flexibility for cutting gears.
Mm-hmm. So what applications would it not be suitable for?
Yeah, there are some limits of the process. One is, for example, parts where we have a very short cycle time. Mm-hmm. So when we are looking to planetary pinions where we have cycle times significantly below 10 seconds, then this process is too slow to keep up with a very short hobbing time. And we have, of course, some shaft type parts or cluster gears when there is a contour adjacent to the gear where we certainly need to evaluate what is possible. And here there are some limits regarding chamfer hobbing.
So does implementing chamfer hobbing require any special machinery or software?
Yeah, we are applying the chamfer hobbing process on a hobbing machine, on a Genesis hobbing machine, which goes up to 160 or 210 millimeter, and it's set up parallel to the hobbing process. Mm-hmm. Yeah, the software was completely developed, totally new, and it allows a very easy operating and setup of the machine and the chamfer hobbing technology. And we have the simulation software, what I mentioned before, in order to upfront define the chamfer, what is possible to achieve. And I think it's important as well that Gleason, in this case, doesn't provide the machine only, but it provides as well the technology for chamfer hobbing. It provides as well the tools. Yeah, they are manufactured by Gleason, so that you basically get a full package, everything out of one hand, and that shows somewhere our approach of the total gear solution provider.
Very good. Gottfried, I'd like to thank you for sharing that information with us today and for joining me.
Yeah, thank you, Randy.